So let us do last property in special function regarding recurrence relation Jn of x. That is prove that d by dx of x to the power of minus n into Jn of x is equal to x to the power of minus n into Jn plus 1 of x, similar to previous property. So first let us take Jn of x. Summation r varies from 0 to infinity minus 1 to the power of r x by 2 to the power of n plus 2r 1 divided by gamma of n plus r plus 1 into r factorial. I should multiply x power minus n to this. So x power minus n into Jn of x is summation r varies from 0 to infinity minus 1 to the power of r x by 2 to the power of n plus 2r into x power minus n to 1 divided by gamma of n plus r plus 1 into r factorial. Now if you observe here, if I take out the term separately, that is x to the power of n into x to the power of 2r and 1 by 2 also separately 2 power n plus 2r. So this minus n and plus n get cancels. So x power minus n into Jn of x is summation r varies from 0 to infinity minus 1 to the power of r into x to the power of 2r into 1 divided by 2 to the power of n plus 2r gamma of n plus r plus 1 into r factorial. So don't get confused with this r and this r, both are same. We can write it together. So x power minus n Jn of x is summation r varies from 0 to infinity minus 1. So now we have to differentiate this, right? So d by dx of this, because we want differentiation of that term. So it is d by dx. So minus 1 to the power of r, 2r into x to the power of 2r minus 1, 1 divided by 2 power n plus 2r, gamma of n plus r plus 1 into r factorial. So r varies from 0 to infinity minus 1 to the power of r into, so this 2 I will take to denominator and I will introduce x power n and minus n once again. So what happens? R into x to the power of minus n into x to the power of n plus 2r minus 1 divided by 2 to the power of n plus 2r minus 1. So this 2 I have taken to denominator. 1 divided by gamma of n plus r plus 1 into this r factorial. I will write it as r into r minus 1 factorial. So that this r and this r get cancelled. Once again, this r and this r I have written differently. No problem. You can write it same. Usually while doing the same summation, it will change. It's okay. You can use this r or this r. Both are same. But use only one type, which I have not done here. But you try to write it the same ways. R equal to r varies from 0 to infinity minus 1 to the power of r. So this x power minus n I can write outside. So into x to the power of n plus 2r minus 1 into 1 divided by, so here 2 to the power of n plus 2r minus 1 I can write together. So 1 divided by gamma of n plus r plus 1 into r minus 1 factorial, because r and r get cancels. So now if you observe, once again we have done this. If r becomes 0, minus 1 factorial. So we should define r from 1. So I will define the summation as r varies from 1 to infinity minus 1 to the power of r x by 2, I will combine this, n plus 2 r minus 1 divided by gamma of n plus r plus 1 r minus 1 factor. Now you know that already we have done this. I will put r minus 1 as s, so that r becomes s plus 1. So if r becomes 1, s becomes 0. If r becomes infinity, s becomes infinity. So x to the power of minus n summation s varies from 0 to infinity minus 1 to the power of s plus 1 x by 2 to the power of n plus 2s plus 2 minus 1 to 1 divided by gamma of n plus s plus 1 into s factorial. So this is nothing but x to the power of minus n into minus 1 into s varies from 0 to infinity. So here one minus I forgot. Here outside minus will be there. So in this result, what we are proving, here outside one minus sign should be there. Okay, so minus 1 to the power of s. So here minus 1, I will take only minus 1 to the power of s I will return. So this becomes x by 2 to the power of n plus 1 plus 2s 1 divided by gamma of n plus 1 plus s plus 1 into s factorial. So which is x to the power of minus x to the power of minus n into j n plus 1 of x. So I can write, therefore d by dx of x power minus n into j n of x can be written as minus x power minus n into j n plus 1 of x. So this is the last property. So all 8 properties are important. Now based on these properties, in the next session we can do some problems which is very simple.